Okay, in this module we're going to be looking at significant figures, specifically significant figures in calculations involving multiplication and division. In chemistry, the most common math operation you do will be multiplication and division. So these 5 problems are examples of problems you could encounter in chemistry. If you look, the first 2 problems are multiplication problems, and they are both 3 times 5. So according to math, if I type these in my calculator, I would get the same answer of 15 meters squared for them. The last 3 problems are all 10 divided by 3. So if I did the math, I'd get 3.3 repeating. My calculator has a 10-digit display, so I would get these answers if I entered them into my calculator. But my calculator just looks at math specifically, so it doesn't account for the precision of my measurements. And a good chemist always accounts for the precision of their measurements. So, the rules for multiplication and division are significant figures based. And the rule is, the answer of a multiplication or division problem must have the same sig figs as the number in the problem with the least sig figs. So let's look at our examples in terms of this rule. In the first example, the first number has 2 significant figures, and the second number has 2 significant figures. So that means the answer should have 2 significant figures, which it does. So this is an appropriate answer for chemistry. In the second problem, the measurements were less precise. So the first number has 1 sig fig, and the second number has 1 sig fig. The answer from my calculator still has 2 sig figs, so this is no longer an appropriate answer. I have to round that answer so that it has only 1 significant figure. And if I round that answer to 1 significant figure, I get a value of 20 meters squared, which has the 1 significant figure that is required. In the third example, we have 1 significant figure in the 10 grams, 1 significant figure in the 3 milliliters. The answer from my calculator has 10 significant figures. Not appropriate for a chemistry answer. Because the least amount of sig figs in my problem is 1, my answer has to be rounded so that it has 1 significant figure. So I report it as 3 grams per milliliter, giving me the 1 sig fig required. Example number 4. 10 grams has 4 significant figures, or 10.00 grams has 4 significant figures. 3.0 milliliters has 2 significant figures. From the problem, the least amount of sig figs is the 2 sig figs in the 3.0 milliliters. Number from my calculator still has 10 sig figs, so it is still not appropriate. I have to round my answer so that it has 2 significant figures, and that would be 3.3 grams per milliliter, having the 2 significant figures required. In the last example, the 10.00 grams still has 4 sig figs. But in dividing it by 3, that 3 has no unit. With no unit, it is not a measurement, it is a counted number. I'm just taking that 10 grams and dividing it into 3 equal pieces. If I divide it into 3 equal pieces, the counted number, sig figs do not apply. So in my given number, the smallest amount of sig figs is still the 4 sig figs from the 10.00 grams, which is the only sig figs in the problem. That means my answer has to have 4 sig figs. The number from the calculator still has 10 sig figs, so it's not appropriate. I need to round that to 4 sig figs, so 3.333 grams per milliliter becomes the appropriate answer in chemistry. Multiplication division, we have to look at the sig figs of our given number and report our answer to the least amount of sig figs. So that means we're going to have to round our answer, and the sig fig rules help us figure out the rounding. Let's try some on your own. Here are 5 problems involving multiplication and division that you could encounter in chemistry. Please pause the video, work through them. When you're finished, unpause the video and we'll go through the answers. First example, 2.00 meters has 3 sig figs. 6.00 meters also has 3 sig figs. So my answer should be reported to 3 sig figs. That means the answer should be 12.0 meters squared. Second example, 1.0 meters has 2 sig figs. 4 seconds has 1 sig fig. So that means I should report my answer to 1 sig fig, which is the smallest sig fig in the given number. So I report that as 0.2 meters per second. Example number 3, the 25 grams has 2 sig figs. The 3 beakers is a counted number. I'm just taking 3 beakers that I have. So their sig figs do not apply to the 3 beakers. The smallest amount of sig figs in the problem is 2 from the 25 grams. So my answer should have 2 sig figs. So I report my answer as 75 grams. Problem number 4. 50.00 grams has 4 significant figures. 5.0 milliliters has 2 significant figures. The 2 significant figures is the least amount of sig figs, so my answer should be reported to 2 significant figures. So I would write my answer as 10 grams per milliliter, or if I would put it in scientific notation, 1.0 times 10 to the first grams per milliliter. In the last example, 11.1 centimeters has 3 significant figures. 3.0 centimeters has 2 significant figures. The smallest amount of sig figs in the problem is 2 sig figs, so I report my answer to 2 sig figs. As I round the answer, I would report my answer as 33 centimeters squared. This ends the module on significant figures in multiplication and division.